All right, so we're going to do group 3-4 this week. You're going to be starting, or we're going to be starting right here with group 3-4. And the first thing we're going to do is add ammonia and hydrochloric acid and thioacetamide. We've got to take it up in pH. Okay, we've already separated out the group 2s, so they're already gone. So now we're going to precipitate out the group 3-4s, and they include cobalt and chromium and iron and manganese, nickel, barium, and calcium. The barium and calcium are the group 4s. So we're going to precipitate them at a higher pH, but again using thioacetamide in order to make their sulfides. Once we've done that and heated it, we're going to centrifuge it again. And the group 4 supernatant will contain the barium and calcium. The precipitate will contain the cobalt, chromium, iron, another iron, manganese, and nickel. The one we're going to play with first, obviously, is group 3, and we'll have some separations going on there. The first separation will be the cobalt and nickel from the chromium, iron, and manganese. And again, I walked you through all these reactions in the concepts video, so please review that if you're uncertain of what's happening. Now we're using hydrogen peroxide and some base here in order to separate out our chromium. The chromium is going to form this chromate, which is actually a polyatomic ion, and at that pH that we're going to be working at, iron is going to form a hydroxide, iron 3 hydroxide, and manganese is going to form manganese oxide. So once we have the supernatant, which is yellow, separated out from the precipitate, we're going to reacidify the chromate, add some barium, and we're going to produce barium chromate, which is a pale yellow precipitate. That's the confirming test for chromium. Meanwhile, back at the ranch, we come back, we're done with this. We come back and take our precipitate, which contains iron and manganese, and we reacidify it, and we use hydrogen peroxide with it. And when we use hydrogen peroxide, we end up again with a supernatant and a precipitate. The precipitate's going to contain manganese in it. And we're going to get to play a little bit with some various chemicals to really give ourselves permanganate, which is that dark purple stuff that we love. The supernatant is going to have iron in it, and we're going to form iron thiocyanate, which is what we used for the equilibrium lab. So it's a bright red solution. All right, so when we're done all of group 3, we're going to come back and take that group 4 test tube that we labeled very carefully so we didn't throw it out or put anything else into it, and we're going to form some carbonates. Okay, we know barium and calcium both form nice carbonates. We've seen that in class. And so we're going to precipitate those out. Barium carbonate, calcium carbonate, and we're going to get rid of our supernatant, and that's just going to be wash. Then we're going to acidify it, but only with acetic acid, so not terribly acidic. And then we're going to add potassium dichromate. When we add potassium dichromate to it, hey, check that out. We're going to get the same confirming test for barium as we got for chromium. So that's kind of cool. You've seen it here, you'll see it here. Once we've done that, we'll take the supernatant, separate it, and add oxalate to it, and we get a glorious white calcium oxalate precipitate. So that's what we're going to be doing today, and then next week, Aaron and I are going to video a situation in which he actually is using a general unknown, which means he's starting with the possibility of having all of these cations in there. First, he works on separating the group 2 and the group 3-4, and then does group 2 just like we did the last video, and group 3-4 just like we're going to do this video. Now, because you've already seen all the heating and the centrifuging and the addition of reagents, we've kind of cut some of that out for this video. We have 16 million test tubes here sitting in front of us that have got bits and pieces at different junctures, okay, so that you'll see some of the important stuff and then the confirming tests. So we're going to get Aaron out of hiding and going to do this thing.
Hi everybody, I hope you enjoyed Professor French's talk with the less colorful flow sheet this time. Now you get me showing you how to actually do everything again. So I will just say really quickly, over here we have a little bit of a cheat sheet because we didn't want to spend 4 hours filming this again, but we're still going to show you all the steps. We just have some things made up already so we on our end don't have to wait for 20 minutes for things to heat and centrifuge. So to start with, here's our group 3 and 4 known that has all of the stuff in it. It came from this bottle, so we just poured 10 to 15 drops into there, and we're going to go with this and see and go through each test and see what everything looks like. So to start with, we add 2 drops of our 6 molar HCl to this. So here we go. Let's see if anything funky happens. Not much. However, we should now be acidic. So, there's my pH paper. Here it is.
I had pH paper out. The kids must have taken it. Here's the stirring rod.
Let's get a few of these out. So I added my 6 molar HCl to that. And yep, that is acidic. So now that we know we're acidic, we're going to add some NH3 until the solution becomes basic. So start by adding a few drops. You can already see some funky stuff forming on the top there.
I'm going to zoom in. Not quite that much. Okay.
You can see our 2 layers, and I'll give it a good mix. And it looks like we got a good amount of stuff forming, so let's check the pH on that. Let's see how well we've done. And yeah, it's not fully blue, that's green, but that's basic. So we're in a basic area. So now that we know we're basic, we're going to add 5 more drops of this. We want to get it really basic. 1, 2, 3, 4, 5. And 10 drops of our friend from last time, 1 molar thiacinamide.
And it begins to smell.
And it begins to smell. So if you look here, if you look closely, you can kind of see it layering. So we're going to give it a good mix. Give it a good mix with this. And now the directions say to heat for 10 minutes. Like I said earlier, we don't particularly want to wait for 10 minutes on our end, so we already did this step earlier. So here's what it looks like after 10 minutes. If you look closely, you kind of got some stuff forming on the side that gives it kind of that mirror glassy look. So that's what's going to happen after you heat this for 10 minutes. And there is still liquid on the inside. I'm trying not to pour it all out, but I'm trying to move it so you can kind of see that. Alright, so what do I do next?
Centrifuge.
So afterwards, we would centrifuge this and we would decant it. And we would get 2 separate things. Our group 3s, which are in the solid on the bottom, which we have here. And we have our group 4s, which would be in the supernatant, which we have here. So we will come back to the group 4s later. We're going to start with our group 3s that we already separated out beforehand when prepping to make this video. So to this, we're going to add 15 more drops of NH3. Ooh, that smells like ammonia. So we do that. And then we centrifuge this again. And I don't think we have this one set up, so I'm going to centrifuge this real quick. So we'll jump and we'll come back in a minute. Alright, so for those of you who are paying extra special attention, extra close attention to the continuity, I did switch out my goggles because the last ones were fogging up. So, but yeah. So now that we've centrifuged it, we've got our black precipitate in our colorless solution.
Hang on, let me get it. There we go. You can kind of see the colorless solution there.
Yeah, and now I'm going to take HCl. Yeah, HCl. I'm going to put that in there. 10 drops. And if you look, you can already see smoke coming off of that.
Let me try to zoom in. Yeah, they can see that.
So yeah, we got a nice smoke coming off of there. Oh, I forgot to discard the supernatant, but it doesn't really matter.
No, it allows them to see the supername better.
Yeah.
And no, it doesn't matter.
It doesn't matter because we already have the next step prepared anyway. So, my blunder, but no harm, no foul. So, after that, we would have heated it for a few minutes, and when we would have decanted that supernatant, we would have been left with, so this would be our supernatant, which has that nice pale purple, maybe pink, depending on what color you decide that is. I think it's a purple. And that has our chromium, manganese, and iron ions. And also, the precipitate for that has our cobalt and our nickel, which we've already added the 15 drops of water to, so that's why it does kind of look kind of wet. It is, in fact, in a solution. But we've separated those out. So we'll come back to the cobalt and nickel in a bit. We're going to stick with the chromium, manganese, and iron for now. So to this, we're going to add 6 molar NaOH to it until it's basic on pH paper, which means we need to test it first. So, get a drop. And that is, in fact, acidic. Got that nice pink color. So, one of these is NaOH. Here it is. So we're going to add some 6 molar NaOH until it turns basic. So let's see what happens. So if you notice, there is a precipitate forming as I do that. There's like a cloud. You can actually kind of see 3 layers. There's this purple on top, this kind of pale blue, and then on the real bottom, it still looks kind of clear. Let's give that a good shake. And now we kind of got that universal, murky, maybe slightly blue color. So let's see what pH that shows up as. So yeah, sorry for the red outside. That blue dot in the center is the spot I just made. So we are now basic. So once it's basic, we will add 4 more drops just to ensure that it stays basic. So 1, 2, 3, 4. Look at that. I can count to 4.
It's reassuring.
And we'll give it a little shake just to make sure everything mixes in there. After that, we're going to add, if I can find it,
What are you looking for?
hydrogen peroxide.
Oh, yeah. I was going to say Ruth took that.
Here it is. We're going to add 6 to 8 drops of hydrogen peroxide. So, that's about 4 drops. If you look now, I don't know if you can hear the fizzing, but you can definitely see the bubbling. Got that bubbling up top. We got a black layer. Got some stuff on bottom. Let's add another 4 drops. Close this. And I'll give this a nice shake to mix everything around in there. Now we've got this kind of black sludge that's giving off bubbles.
And
So yeah. So
using
now,
the stirring rod to get everything.
yeah, so let's mix that around in there just to make sure everything's out, because hydrogen peroxide, not the most fun stuff in the world. Now the instructions say, mix thoroughly, wait, heat to destroy the stuff, and then centrifuge. Once again, we don't particularly want to do that, so we made it up beforehand. Here's some chromium. We have a yellow supernatant, and the rest of the stuff came off as a precipitate over here. Here's our manganese and iron. So here's our yellow precipitate for chromium, and we're now going to continue with the chromium test. So it says to acidify our supernatant, which means before we do that, let's test where we're starting at. Oh, that's a dark blue color. That's proper basic. So we want to acidify it with 6 molar acetic acid. So here's our 6 molar vinegar. A little strong to put on your salad dressing, but smells just as vinegary. So let's add some drops to this and see what happens. If you look, I don't know if that'll appear on camera, there's a really light smoke coming off of that, but there isn't really any major change. I'm going to add a couple more drops for the fun of it. Give it a good mix, and let's see where we end up. Oh, that smells like vinegar, all right.
Yeah, it sure does.
Look at that. I'm actually neutral. That was the right amount to be perfectly neutral. Let's add a few more drops of that, shall we? All right. 4 drops should be enough. What on earth?
Well, remember, this is acetic acid. It's a very weak acid, so it's not going to turn anything other than slightly orange of neutral. It's something that people always get concerned about. It's sort of like making something basic with ammonia. It only gets green, it doesn't go blue.
I mean, is that good enough? It's not really showing up on here.
No, it's not really showing up. But I think that's probably fine.
All right.
If it doesn't turn out, it's not fine.
Yeah. Consensus from Professor French. We're going to keep going.
Yes.
So, hope you enjoyed that. All right. So
It is true, guys. Acetic acid is a weak acid, so you would have to add a whole lot more of it than you would like 6 molar HCl in order to have the same acidification power.
Yeah. So after that, we add 5 drops of our barium chloride, and hopefully this will actually show us the chromium ion.
Here it comes. Yay!
And if you look there, it's become a very pale, almost white cloudiness. So that is our chromium ion. Or I guess it's chromate now. So it's not even chromium, but it confirms the presence of chromium originally in there. So that is what we're looking for. Let's add a few more drops for the fun of it. There's barium chromate. We did in fact have chromium in our known solution. So we're going to pause for 1 second so I can defog my goggles, and then we'll continue with the other ions.
Oops. You're on.
All right, so here is our precipitate that has our manganese and our iron in it that we're going to test for. So with that, we're going to add 10 drops of 3 molar sulfuric acid, if I can find it.
Right there, the teal colored to the right there.
Ah, there it goes. All right, so add 10 drops of that to this. Let's see if anything funky happens. So it's definitely lighter now. We've gone to more of a tannish color than that brown before, but that's probably just because it's There's more liquid in there to dilute it. And we're also going to add 10 drops of H2O2, hydrogen peroxide. And there was a definite color change with that. We were almost pretty much colorless at this point. And the instructions say to heat for 10 minutes or something like that. Heat for 4 minutes, centrifuge and save, yada yada yada. We've already done that for you. So we're going to move on to the manganese. So the manganese is in fact already in solution for us. We don't have to add 10 drops of water to that. So we're going to add 10 more drops of the H2SO4. We're going to do that again. Here's our color solution. If you look closely, there is a little bit of a white precipitate at the bottom, but we're going to work with the rest of the solution. So there I go, showing off my wonderful counting skills again. Now we can see I got up to 10. Give it a good shake. That white particulate isn't really anything new showing up. That's just that little bit of white precipitate that was already there at the bottom. And we're going to add 10 more drops of the H2O2 again. So give that a shake. And there isn't really all that much excitement going on there, sadly. Still pretty much a colorless solution with just a little bit of solid at the bottom. So now we do not have the next step for this made, so we're going to pause for a moment while I heat this for a minute or two, just to destroy any excess H2O2.
You want to just work on the iron while you heat that? Because the iron doesn't require heating.
So Professor French is telling me to move on to the iron while I do that. That's not the order that it's in the book, but the iron is an easy enough step that I think you guys can handle moving out of order a little bit. So I'm going to go put this in the hot bath for a few minutes and work on the iron. We just turned that hot bath on as well, so it's not fully hot anyway, so it can sit in there for a couple extra minutes. So here is our solution with the iron. It is also a colorless solution. Not much going on there, but we're going to make some stuff go on there. So, does this already have the water in it, or dilute it more?
What does it say?
It says to dilute with an equal volume of H2O by I.
I think I did not do that.
All right, so we're going to dilute this. We're going to put some more water in there. So I'm going to pretty much just double the volume approximately. Any of you with a ruler strapped to your computer screen, if I'm not exactly, I apologize. This is approximate. Looks like it's about double to me. Still a colorless solution. Beer's law doesn't have anything to do with colorless solutions. So then we're going to add 5 drops of KSCN, which is
Down the orangey towards the end. Isn't that? No, that's ammonium.
That's ammonium. This one.
Oh, there we go.
So we're going to add 5 drops of this. And we got a nice wine red color. I'll give it a good shake so it goes all the way through. Yeah. We got a nice rosé there. Reminds me of the bottle of rosé I have in my fridge that I should drink when I go home. So that is our iron. We have officially made iron. So we're going to pause the video in a second.
Iron thiocyanate.
Iron thiocyanate. I apologize. We haven't made pure iron metal. We made iron thiocyanate. We're going to pause the video for a second to let that decompose some more, and we'll come back to test for the manganese. So I've taken this out of the hot bath. We've gotten all of the excess H2O2 out of there. We heated it and decomposed into water and oxygen gas. So since we decomposed in water, this is probably a dilute solution now. So we're going to dilute it even more by adding more solution to it. However, this is going to be 6 molar HNO3. So don't know why I still have these in the tongs. So it says to double it by eye, so just like I did with the last one, gonna eyeball it. Don't come at me with a ruler. Alright, I'm good calling that about double, approximately. So I'll give it a good shake to make everything homogeneous. We got a nice acidic solution. There's a little bit of a particulate in there from before, but we're going to keep going with it. So now we're going to add some of our NaBiO3. And I think that the instructions say a tip full on a spatula, but we have our own special technique of doing that here. We take a pipette, just kind of do that. So,
And then the trick
Yeah.
is trying to get it out.
and it's going to do that. And my fingers are smoking. Now we're going to do that a whole bunch of times. I didn't even get all that out the first time.
Ooh.
No, that's fine.
Yeah, you're not going to need all of that. So you don't want to overdo and have it go over the edge.
So you can see there's some stuff still settling on the bottom over there. So we got this like white cloudy solution, and we have solid on the bottom. And we're going to do this a few more times. So it just do this until it stops bubbling, basically.
Yeah, a little more.
Alright, so it's pretty much stopped bubbling upon the addition. So we think we're done.
This we do have to centrifuge.
So we do now. You can see there's some stuff on the bottom there, but the solution is all cloudy as well. Sorry about that. There's some stuff on the bottom, but the solution is all cloudy as well. So we are going to centrifuge this quickly. So we'll centrifuge it, and then we'll come back when it's done before moving on to the rest of our group 3s.
Okay.
Alright, so we finished centrifuging it, and we've got that bright purple magenta color, almost like over-titrated phenolphthalein. That really pretty color that I want to paint my bedroom one day.
You.
Yeah, Professor French doesn't like it when I say that.
No.
But yeah, here is our manganese, this really pretty pink, magenta, purple, whatever you want to call that. So now we're going to go on to our precipitate from way back to test for nickel and cobalt. So remember when I mentioned it earlier, we said we put it in a bit of water. That was to prevent it from like drying out. We have since taken that water away, so that is mostly just our precipitate at that point. So we are now going to add 4 drops of HCl and 6 drops of HNO3 to make it pretty much as acidic as we can.
What is that called? I can't remember. There's a special name for that particular combination, but I'm drawing a blank right now.
Aqua Regia.
Yes, that's it.
Yeah, we're making a fun thing called Aqua Regia, which is the only acid that's strong enough to dissolve gold. Fun fact for you.
I didn't
It's
know
also
that.
very unpleasant. I know that because I had to make gold nanoparticles with Dr. Foddy.
There you go.
I got to play with Aqua Regia. That was really fun to neutralize, just so you're
I
aware.
can imagine.
So, got our acidic solution of Aqua Regia, of HCl and HNO3. And we're going to dilute this by eye, so we can divide it off and have our stuff, which you didn't do already for me.
No, we have
So,
lots of test tubes.
For those of you who have done advanced chemistry, you might have heard the saying, do as you oughta and add acid to water. We're doing this the wrong way. You're not supposed to add water to acid, so
What?
we're living on the edge in Gen Chem, guys. So dilute it by about double. It's Probably a little more, but that's fine.
Yes, it'll work.
I'll give it a good stir.
I'm really a little surprised that didn't dissolve.
Should I add more acid to it? Okay, apologize for that edit there, guys. We did forget to boil this, which is why that didn't dissolve immediately. This is what it should look like. So, we've got our nickel and our cobalt dissolved, and we're going to split this into 2 different test tubes, so that way we can test for both the things that are in the solution.
I just got off screen. Go ahead.
There was a little bit of residue behind in there, like it says in the procedure. We took that off camera. You didn't need to see that. So, here's some other test tube. Gonna be picky. That one looks clean. So I'm going to pour about half of that into here. Let's do a touch more.
Beautiful.
Right, there's still a little bit of solid in there, but we'll survive.
It won't interfere.
So it doesn't matter which one I test for what, because they're the same solution. So this one, I will test for nickel. So I'm going to add 10 drops of ammonia to us, NH3. And this is to make sure it's basic, so like I've been doing before. Test our starting point. Making a mess of napkins over there. And see, we are starting acidic. So, this one? Yeah. 10 drops of NH3. Give it a nice swirl. You can already see that's become slightly more yellow with the addition of that. Hold up to my shirt. Oh, that's not even slightly yellow. That's just become yellow.
Mm-hmm.
And just to be certain, there's our blue spot. There's our green spot, really. There's our basic solution of ammonia.
Again, guys, ammonia is a weak base, so 6 molar ammonia is not going to have as much base power as 6 molar NaOH or KOH.
So it does say that if a rust-colored precipitate starts to appear, which it does look like they're appearing, we should centrifuge it. So we're going to stick this in the centrifuge. No, Professor French is saying no. All right, we're not even going to bother. There's not enough precipitate in there for us to worry about. So thank you for saving us that time, Professor French, behind the camera. So we're going to add 5 drops of DMG reagent. I don't even know where that one is. I don't remember seeing it.
I think it's on in the glass bottle on the other side of the thioacetamide. Nope. Yeah. The reason I'm not worrying about the iron...
This
no,
is methylviolet.
Here.
Oh, this one.
About the little bit of iron 3 hydroxide is because there's so little of it, it's not going to interfere with the next test. If there was a lot, then it would interfere.
All right, so we're going to put DMG reagent. Professor, you want to tell us what DMG is?
Dimethylglyoxime.
Cool, I didn't know that. I'll admit to that.
Don't ask me to draw it. That would not happen.
I'm going to add 5 drops of that. Oop.
Oh,
That has a smell to it. So you can already see...
that's blurry.
Is it fixed?
Yeah.
So you can already see we've got that nice rust color coming on top. Give it a good shake.
It's actually salmon, but, you know, who's...
Okay, salmon colored, rust colored. Yeah, I guess it looks a bit salmony now. So the formation of that salmon color, I think, is our nickel.
Mm-hmm.
Yeah.
It sure is.
I remember it being like a hot pink.
Well, if you spun it, if you put it in the centrifuge, oh my goodness, you'd get a hot pink precipitate. Or it seems to be salmon colored, hot salmon colored. I don't know if our reagent's old.
Well, the next time we have to centrifuge something, I'll stick that in the centrifuge so I can hold it up for you to see later. But right now, let's move on to testing our cobalt. Is our cobalt? Yeah. So here's the other half of that solution. To that, we're going to add a small portion of sodium fluoride using the tip of a spatula. This one we are actually going to use the spatula for.
And this is very, very nasty stuff, guys. This is a very toxic substance, so we're being very, very careful with it.
By that, we mean I'm going to spill it everywhere.
No, you're not.
Well, this is flocculent.
What?
That's an SAT word I learned from Dr. Rossiter, which means it's very powdery and likes to blow all over the place.
Oh, okay, because I thought it sounded like a curse word, but anyway.
Flocculent.
You learned something new, guys, right?
Yeah, so I'm going to add that tipful into there. Put this away. So it says there may not be a dramatic reaction, and there isn't really a dramatic reaction. I'll give it a good stir, a good mixing.
You do have to have enough so that there's some left over on the bottom. Do you have some left over?
Yeah, I have a whole chunk of it left over.
Okay. I can't see.
Yeah, so if you just heard what Professor French said, there should still be some left over, so we know we're completely saturated and completely reacted. And there is a decent chunk of that left on the bottom, as you guys can hopefully see.
Oh yeah, there it is.
So now we're going to add some ammonia thiocyanate to that, which is
That's
this
that one. Yeah.
We're going to add 20 drops. We're counting up to 20 now, guys.
This could be a challenge.
Could be a challenge.
He's going for his doctorate. That doesn't mean he can count. Check it out.
My doctorate's in organic chemistry, so we don't need to count for that one.
Yes, you do. Okay, hold it in front of your coat, please. There we go.
So you can see it's kind of separated, and that nice blue color there is our cobalt. I'll give it a good mix so you can see it. Look at that.
So
there
pretty.
is our cobalt. So we're going to, let's pause the video for 1 second, and in a moment we'll come back and do the group 4s. Alright, so we finished the group 3s, and now we're going to move on to the group 4s. So here's our supernate from way back when. And to this we're going to add 15 drops of ammonium carbonate. Which I think is this? No, that's
oxalate. Right here. No. Yeah,
There.
there.
Going to add 15 drops of that.
Oops. Sorry, guys.
I stopped counting while I was doing that, so I think I went a little overboard. But if you notice, it's become a little bit discolored, so I'll give it a good mixing. Now, the instructions say to mix thoroughly in centrifuge. We've already done that. And we end up with this like silvery mirror-like substance on the outside again. And I'm going to discard our liquid from that. Ooh, that smells.
Uh-huh.
That smells. And we're left with that. And we're now going to add 5 drops of 6 molar acetic acid. We're adding vinegar to rotten eggs. That's such a great smell combination.
Oh, hissing. Hissing, bubble, and stink.
So I don't know if you can hear that, but it's hissing and it's bubbling. It's quite stinky. And it says to heat that for 30 seconds. So I want to heat that for 30 seconds. So
We'll just wait while you count to 30 slowly. I'd sing for you guys, but, you know, that would just be miserable. Aaron could sing for you.
I can sing for you. I have sung Carnegie Hall before. I'm very proud of my singing voice. But that's for a more casual
I know, but since we're waiting
conversation.
Okay.
So I'm going to let that heat for a few minutes, and I'm going to add some more acetic acid. Probably been about 30 seconds already.
Yep.
Well, Heat only makes that smell worse. Where'd I put it? So I'm going to add 3 more drops of the acetic acid. So now we're properly acidic. I'm going to add 10 drops of potassium dichromate, or potassium chromate rather, just regular chromate. If you look at that, the solution's kind of become like a cloudy yellow color. It's mixing with all the gunk in there. And it says to heat for 1 minute and then centrifuge. However, we've already done that. So I'll just place it over here.
Yeah, the gunk goes away.
The gunk goes away, and we're left with a yellow precipitate. So a little bit of liquid in there, but that's our barium. We've got a nice yellow precipitate. Sorry, I was out of view. So now that we've done that, so we discarded the supernatant, and we've kept that over here. Got rid of all the gunk. I'm going to now test for our calcium. And for that, we're going to add 2 drops of the ammonium oxalate. That was the thing that I thought was ammonium carbonate before. Say 10 drops?
Everybody
10
makes
drops.
that mistake.
It's 10 drops of this. You can already see a nice yellow precipitate coming out. Mix thoroughly. And we can see a nice yellow precipitate coming out of there. We will centrifuge this for you in just a second, but that precipitate does mean that we have confirmed the presence of calcium in there as well. So we are done with the group 4s. So
Okay, you can go ahead. Well, I centrifuge. You could go
Oh,
ahead
wait.
and show them the.
I'll pause video.
There you go.
All right, so with that, we've done all the cations, and like I did with the group 2 video, I just want to go through this really quickly. Again, at the end, we've centrifuged everything down so it all should look nice. So from start to bottom, here is our chromium. You got that yellow precipitate in a clear solution at the bottom. It's not a lot of chromium there, but it is there. You can see it. Next, we got the manganese, which is the purple solution, not the stuff at the bottom. That really pretty solution that I want to paint in my bedroom.
Just don't even go there.
Next, we have our red wine for iron. I will admit that we did remake this off screen because we lost it somehow. Don't know where it went, but we wanted to show it to you again. So this isn't really rosé anymore. This is a dark red, but still looks like wine. We spun this down for you. This is our nickel, so we got that salmon pinkish precipitate there at the bottom for you to see. And last from our group 3 is our cobalt, that nice bright blue teal solution. And from our group 4s, we got the barium, which is once again a yellow precipitate. And we got our calcium, which is that white precipitate at the bottom. There's a little bit of an impurity in there, so we apologize. One last thing that I just want to note for you guys who are looking at the chemicals at home, you might notice that our barium and our calcium, they look a little different because one solution is more dilute than the other, but they are in fact
Barium and chromium.
barium and chromium. Did I say calcium?
Yeah.
Barium and chromium are actually the same compound because we just added them to each other for the different groups basically to get them to come out. So these are both barium chromate to test for the barium and the chromium. So thought you might want to be interested in that. So I hope you enjoyed that, and next time we'll do an unknown where we'll only see some of the pretty colors. Bye bye.